So I'll start the PowerPoint. I'm sharing my screen with you.
Okay, he should be able to.
Can you see my screen?
Yes.
Okay, yeah. So
Can you see?
yeah, so you can see the PowerPoint. So Arnav and
Make sure he can.
Arnav and Rahul can do this PowerPoint.
Alright. Even though I'm a programmer, I'm still going to explain this to you with Arnav.
Microphone.
Cannot hear.
Microphone is here.
You have to speak a little louder.
Okay. Alright, so this is the eBoard Robotics CAD presentation for like the graphic design and stuff. Here you go. This is our first slide. Arnav, can you explain?
Alright, so these are early sketches of the.
Okay.
These are early sketches of the robot. The first one is an early sketch of the robot. The second one is a sketch of the electronics that go with the robot.
Yeah, we wanted to get an understanding of the flow first before we actually started making the robot.
So yeah, so first we designed our designs on paper before we actually moved into CAD designs and actually building everything.
So we.
Okay.
So
First, relic recovery. Okay. That's again.
yeah.
Yeah.
So, yeah. Our creative in it.
So, caution paper. Did anything we would think about the handpoints of the design? We debated with each other on what part, the most important part of our design process. Okay, good.
Alright.
Good idea. You did a lot of brainstorming it up here.
Yeah, we did.
Yeah,
That's
we
what
did
each
some-
of these designs.
So for each of these pictures we listed the pros and cons of each design, and then we analyzed each design, and as you can see here the writing. So that helped us choose a really nice design to make our final robot.
Yeah. These are like all. I'll do this one. So,
Speak a little louder.
so.
No.
Yeah, so these are the early chassis that we have, and chassis are obviously like the foundation of the robot, yeah. So this is like really early, this one like right here,
No,
That
just say
one,
the
yeah.
top left.
the top left one. It's like a really basic sketch on CAD.
And
It's using Inventor, Autodesk Inventor. This is on PTC Creo, the middle one. That's with a little more mechanics inside. In the bottom right is it's like a more graphic view of like all the dimensions and things of the first one.
so now we went on. Yeah, now we went on to
Early drivetrain.
early drivetrains. Now we went on to actually building models of the chassis themselves, like building different models. So as you can see, we have different models. The first one and the most detailed one has the electronics and everything. This the one in the middle is another design we had in mind, so the robot can move anywhere. And then the top right one was a design that Mahir made on PTC Creo, which is a CAD software. And the one on the bottom right was a design that I made on PTC Creo. And yeah.
Bear in mind that whenever we made any of these, we would always take input from our coaches and our teammates before doing anything. So really, it's not one person who did this. It's the entire team who made these designs.
Okay. You have 4 wheels. Go back.
Yeah?
Go back.
Yeah?
Go back. You have 4 wheels, right?
Yeah.
Yeah.
And the axis of the wheels or the axis of rotation of the wheels are perpendicular to each other.
Yeah.
Mutually perpendicular. Right?
Mhm.
Just show the other picture. Yeah, here, for example.
Yeah.
This is one axis.
Yes.
Two, perpendicular to the first, third is perpendicular to the second, but parallel to the first. Okay, now I got the idea. Why did you put them like this? In the
So what we decided to do is we decided to put the one wheel on each side because we used a special type of wheel called an omni wheel. So the way we put our wheels, we can make our robot go in any direction without having it turn. It could just like move left, right, up, down.
Yeah, like as you can see, like those black dots on each of the wheels.
They're
They
rollers.
look like they're rollers. They huh?
Hello?
Yeah.
Supposing you had put the four wheels like in a car, four wheels and four parts of
Yeah.
the chassis,
Yeah.
it have worked. These special wheels I mean.
See, Amar Mama, the thing is, you see, like on these Omni wheels, they have little black dots, and those are rollers. So this is allowing us to turn easier.
That's okay.
Yeah.
I'm not is working now, right?
Yeah.
But why did you put it like this? That's what I'm tomorrow when you go and face the referees or umpires or whatever it is, they're going to ask you that question. Right?
Yeah. So.
They'll ask you, why did you put these four wheels in this fashion and not in the regular fashion for a car?
Yeah, so one of the main reasons is the field that we're playing on is extremely small, so we want it to be able to spin really quickly. And in order to spin really quickly, these wheels help us because with the car, the radius of turning is a little bigger than with this one. And also,
You keep all these answers ready.
yeah,
Yeah.
These answers ready.
yeah,
Tomorrow somebody is going to question you. I know why you have done it this for. That's because I know all these things. Otherwise, I have seen these
Yeah.
wheels, I have used these wheels, and I know. But somebody who comes there to evaluate you might wonder why you have put the four wheels like this. This is a very good idea,
yeah,
in my opinion. Yeah. That's nice. Go
Yeah.
ahead now.
thank you. Yeah,
So these are different mechanisms we came up with. So the one on
Particularly,
one on the far right is what we call a vertical lift. Basically, we utilize drawer slides and a claw. So the drawer slides, it's kind of like it makes the claw go up and down, and the claw has the ability to grab two 6x6 cubes at once.
And grabbing these cubes gets us points in the game
Yeah.
and putting them on racks. So this is why we have the slide. To like the linear slide, we use that to like move the glyphs that the claws grab up and down, and then like when we move the robot forward, it places them on the shelves, which gets us like points, so we can win.
Yeah.
That's the basic idea.
you need because the attached claws can rotate and pick up multiple blocks at a time.
Yes.
Okay, good, great. So you can pick up more than how many?
We could pick up two. We could pick up two
That's the rule.
at
Yeah.
a time.
Two is the maximum.
Two is
Yeah, but the name for these such grippers. Okay,
okay. We got it.
that name is biscuit gripper.
Yeah. Biscuit gripper.
biscuit gripper.
Yeah.
Oh,
Not
okay.
that it picks up biscuits.
We should write
That's
down.
the name. In industry they call it biscuit gripper.
Make a note. Oh, yeah.
Okay. So this.
Keep it in mind.
Yeah, we'll write that down.
So this is
Yeah,
the.
but I don't know whether today it is being used. The technology is changing very fast in this robotics.
Yeah.
Okay, so this good idea I said. They're using two simultaneously put up. Okay.
Yep.
Yeah. So right now we're moving away from like parts and drivetrains and things, and we're actually starting to build up now because we progressed like we've progressed like pretty far into the season here at this point. So what these are like basic CAD designs of what we thought we were gonna use, and these designs are like all incorporated into the actual robot. See this one? You can see like the claws. This is the first design of the claws on the left, all the way on the left, and there's no like slide yet. So this is like a basic. This is a basic design. This is like the right one on the far right. This is a complete back of the robot that we like the basic idea of the
Yeah, this
robot
is-
we made, and it's like our most advanced design. Like we're kind of using this. We used the design for like a meet that we recently had. We attached wheels, obviously, and we incorporated like more mechanics inside of it. But that's like the basic. It's like the basic block that we had on the far right.
Yeah,
for our,
These two designs are basically sketches of like the robot as a whole.
yeah.
So-
And we incorporated like little things of each into the entire robot. So these are like really important
Just
ones.
answer these questions
Do you have any questions
Yeah.
so far.
so far?
How are you driving this movement?
We what? Wait, can you repeat it first?
How
Oh,
are you?
we're driving it through a remote control. So it's, the programmer is gonna program the robot, and we drive it through a remote control. So like a type of remote
How many
control.
motors do you have there?
How many motors?
How
Right.
many
We have two different types of motors. For the DC motors, we have 6, and for servo, I think we have 4.
Yeah.
4. We have 4 servo and 6 DC motors.
Yeah, 8 is the max amount of DC motors we're allowed to use, and 12 I think is the max amount of
8 is the
servos.
max.
Yeah, of DC motors. And right now you don't see like all these motors because like as we told you earlier, these are like basic, like the bare roots of our robot.
Yeah.
So
So
we're
which motors are these? Is
uh,
there a name for the main,
So
Well-
for the motor?
so the DC motors
Our Tetrix.
are so they both come from the Tetrix, a company named Tetrix. So
Okay, how do you control the speed?
how do I?
Control the
s- the programmer does that.
yeah,
Like
we input programs.
we input programs through Java.
There will be a controller
Yeah.
which will drive the motor. There will be a driver, motor driver.
Mhm.
Does that come with the motor?
Yes.
Yeah.
Yes.
Yeah. Alright.
That's good.
Alright. So
Yeah.
So this is the geometry. So to the far right, you could see the mass, the area, and the volume. And to the left, this is like a sketch of our final design.
Yeah, like you can see all the motors and stuff. It's like we made it a
So
bit
this stage
invisible.
using an app available from the
Oh,
what the
we used-
manufacturer.
Basically, we used a program called Inventor Professional 2018, and it's a CAD software.
Yeah, that software must be having these components embedded in it, right?
Yeah.
Yeah.
Did it have or did you build
It
Uh,
has.
these pictures of the components?
It had it itself, but yeah. But first we needed to build the robot so then we could measure the dimensions.
Yeah.
So
Yeah.
so then this is
Yeah.
a geometry of the robot through the actual program. So it has the mass, the area and the volume. The mass is supposed to be in pounds, not in
How did you could you calculate the mass?
it,
After
you take the weight and you divide it by gravity. That's how you calculate. That's how the program calculated the
Stop
mass.
करके वापस करना है because otherwise you do not.